In mathematics, arg is a function operating on complex numbers. It gives the angle between the positive real axis to the line joining the point to the origin, shown as phi in Figure 1, known as an argument of the point. Definition: an argument of the complex number z equals x plus iy, denoted argz, is defined in two equivalent ways. Geometrically, in the complex plane, as the angle phi from the positive real axis to the vector representing z. The numeric value is given by the angle in radians and is positive if measured counterclockwise. Algebraically, as any real quantity phi such that, for some positive real r, the quantity r is the modulus of z, denoted z. The names amplitude for the modulus and phase for the argument are sometimes used equivalently. Under both definitions, it can be seen that the argument of any complex number has many possible values. Firstly, as a geometrical angle, it is clear that whole circle rotations do not change the point. So angles differing by an integer multiple of 2 pi radians are the same. Similarly, from the periodicity of sin and cos, the second definition also has this property. Principal value. Because a complete rotation around zero leaves a complex number unchanged, there are many choices which could be made for phi by circling the origin any number of times. This is shown in Figure 3, a representation of the multi-valued function, where a vertical line cuts the surface at heights representing all the possible choices of angle for that point. When a well-defined function is required, then the usual choice, known as the principal value, is the value in the open-closed interval. This represents an angle of up to half a complete circle from the positive real axis in either direction. Some authors define the range of the principal value as being in the closed open interval 0, 2 pi. Notation: the principal value sometimes has the initial letter capitalized as in argz, especially when a general version of the argument is also being considered. Note that notation varies, so arg and arg may be interchanged in different texts. The set of all possible values of the argument can be written in terms of arg as covering space. In informal situations, arg may be left not well defined. For instance, argz, where z depends on a parameter t, may change by 2 pi every time z goes around the origin. This idea can be made more precise by considering z as being defined not on the complex plane but on a covering space. Polar coordinates excluding the origin and with an unconstrained angle provide such a space. In this case, arg is defined by the covering space as equivalent to the punctured complex plane, and has as base space the product of a positive non-zero radius and an angle on the unit circle. The principal value arg then maps the covering space of this representation to the interval as the principal value in the range, as y, x is slope, and arctan converts slope to angle. This is correct only when x greater than 0, so the quotient is defined and the angle lies between minus pi 2 and pi 2. But extending this definition to cases where x is not positive is relatively involved. Specifically, one may define the principal value of the argument separately on the two half-planes x greater than 0 and x less than 0, y greater than 0, y less than 0, and then patch together. For the variant where arg is defined to lie in the interval 0, 2 pi, the value can be found by adding 2 pi to the value above when it is negative. Alternatively, the principal value can be calculated in a uniform way using the tangent half-angle formula, the function being defined over the complex plane but excluding the origin. This is based on a parametrization of the circle by rational functions. This version of argument is not stable enough for floating-point computational use but can be used in symbolic calculation. A variant of the last formula which avoids overflow is sometimes used in high-precision computation. Identities. One of the main motivations for defining the principal value arg is to be able to write complex numbers in modulus argument form. Hence, for any complex number z, This is only really valid if z is non-zero, but can be considered as valid also for z equals 0 if arg is considered as being an indeterminate form rather than as being undefined. Some further identities follow.